I'm going to talk in this video about how to factor a polynomial. First of all, what do you mean by factor a polynomial or factorize? It simply means that I have to convert the polynomial, or I have to write it as a product of factors. Something like this. A factor, another factor, maybe more, I don't know. And of course, I have to have a product in the middle. So that's what factoring an expression simply means. I will talk in this video about these four cases, which are taking a common factor, difference of two squares, perfect trinomials, and the difference or sum of two cubes. Let us start with the first case, which is taking a common factor. It simply means that I have to take the greatest common divisor between the terms in an expression. In number 1, for example, I have 3x to the power of 4 and 12x to the power of 3. I first start with the numbers. So I have 3 and I have 12. Is there any common factor between 3 and 12? In other words, is there a common divisor between 3 and 12? The answer is yes, it is 3. And I repeat, it doesn't only have to be a common divisor, it must be the greatest possible common divisor in the expression. And in this case, again, it is 3. So the common factor between the numbers is 3. What about the letters? Do we have an x here? Yes, as well as in the second term. In this case, I take the x with the lowest exponent. So I have x to the power of 4 and x to the power of 3, which means I grab x to the power of 3. So the entire common factor becomes 3 times x to the power of 3. In the next step, I have to write inside these parentheses what is left from each term. In other words, I have to divide every single term by the common factor that I just took. So 3x to the power of 4 divided by 3x to the power of 3 is simply x. So x is left from the first term. I write the minus. What about the next term? We have 12 divided by 3, that is 4. And x to the power of 3 divided by x to the power of 3 is simply 1, so we just write it as 4. And this is the final answer. So it is 3x to the power of 3 into x minus 4. Similarly, in the next example, we have 3 terms here, 1, 2, and 3. We start with the numbers. So we have 18, we have 24, and we have 12. What is the greatest possible common divisor here? Well, it is 6. 6 divides 18 as well as 24 and 12. Well, again, I repeat, you might say, well, 3 is a common divisor. Yeah, but it's not the greatest common divisor, I repeat, so it has to be the greatest common divisor. So it is 6. What about the letters? I check them letter by letter. So we have x to the power of 3, x to the power of 2, and x to the power of 4. This means the letter x exists in each term. So this means that x to the power of some exponent will be a part of the common factor. But what is this exponent? Well, as we said, it's the lowest exponent, that is 2. So it is x to the power of 2. I repeat the same process. I have y squared, y, and y squared again. This means I take the y. We have z, z to the power of 4, but there is no z here, so z is not a part of the common factor. Now we move on to the next step, and we just write the remaining terms inside the parentheses. So we have 18 divided by 6, that is 3. X to the power of 3 divided by x to the power of 2, that's x to the power of 3 minus 2, which is 1. Y to the power of 2 divided by y to the power of 1, that is y. And z remains as is because there is no z in the common factor. Plus, again, 24 divided by 6, that is 4. There's nothing remaining for x because it's just x to the power of 2. And divided by x to the power of 2, so nothing is remaining regarding the x. Same for y. So we just have z to the power of 4. Minus 12 divided by 6, that is 2. X to the power of 4 divided by x to the power of 2, that is x to the power of 2. And y squared divided by y, that is y to the power of 1. And that's the very final answer. Number 3, we have two terms again. This is one term and that's another term. So is there any common factor here? Well, we have 2x minus 5. That is the common factor we have in this expression. So I take it out. And what is left inside? From the first term, we have 2x minus 5 to the power of 2. I already took 1 as a common factor, so I'm left with another 2x minus 5 to the power of 1. From the other term, this 2x minus 5 is taken already, which means I'm only left with x plus 7. Do I stop here? No. I have to simplify the terms inside. I have to simplify the expression inside. So I copy the 2x minus 5, and in the other parentheses we have 2x minus 5 plus x plus 7. I add and end up with 3x plus 2. Again, I have to make sure whether there is another common factor in each of these two factors. Like we have 2x and 5. There's nothing that could be taken as a common factor, as well as 3x and 2, which means that's the final answer. That's the simplest possible form. In exercise 4, if you notice here, we have 3x minus 1 and 1 minus 3x. So they are kind of similar, but the terms are swapped. This means I first have to apply an additional step before proceeding, because I cannot take 3x minus 1 and 1 minus 3x. They are not the same. Like 2 minus 5, for example, is not the same as 5 minus 2, which means these two terms are not the same. However, if this were 3x plus 1, for example, and 1 plus 3x, we don't care because a plus b is similar to b plus a. So we do not care. We only care if you have a minus in between. So what do I do? Well, I'm going to copy the first term, 3x minus 1, multiplied by 5x plus 2. My goal here is to convert this into 3x minus 1 times x plus 4. So I must swap these two terms. Can I do that? Yes, but I have to change this outer sign, which becomes plus. So whenever you swap two terms and there is a minus in between, I must change the outer sign. Now, I can see the common factor, that is 3x minus 1. I take it out. And what is left inside? That's 5x plus 2 plus x plus 4. If you add the other factor, you will get 6x plus 6. And here I cannot stop. Why? Because another common factor pops up in the second factor, that is 6, which means I must proceed, otherwise the factoring is incomplete. So it's 3x minus 1 times 6 times x plus 1. I can simply keep it like that, or I can move the 6 at the front like this, which means it is 6 times 3x minus 1 times x plus 1. That is the final answer. And by the way, can I move the 6 like that to the front? Yes, of course. It's simply like if you're saying 2 times 3 times 4, or 3 times 2 times 4, it doesn't matter. The order does not matter with multiplication, so the answer remains the same. We now move on to the second case, which is the difference of two squares. It simply means that whenever you have a squared minus b squared, I write it as a plus b into a minus b. Where did I get this from? Well, in a previous video, I explained the special products of polynomials, and this was one of the formulas. So whenever you have a perfect square minus a perfect square, I immediately apply the difference of two squares formula. In example 1, we have 81x to the power of 2 minus 16. So of course I must have a minus in the middle because it's a difference. Is 81x to the power of 2 a perfect square? Yes, it is. I just want to add one little remark here. It is a very important remark in any factoring problem. Whenever you have any factoring problem, the first question that you should ask yourself is the following. Do I have any common factor? No matter what the case is. If yes, I take a common factor and then proceed if there is any other possible factoring. If not, I just head up and continue with the convenient formula. So for example, here we have 81x to the power of 2 minus 16. Is there any common factor between 81 and 16? Is there any common divisor? The answer is no. This means that there is no common. Now I proceed to the other case. And here in this example, it is just the difference of two squares. Why? Well, because it's a difference. And 81x to the power of 2 is a perfect square. It can be written as 9x to the power of 2. And the 16 is 4 to the power of 2, which means the 9x is our A and 4 is our B. So the final answer becomes A minus B, or 9x minus 4, multiplied by A plus B, which is 9x plus 4. That's the final answer. In exercise 2, we repeat the same process. So there is a difference in between. And of course, again, there is no common factor here between 16 and 1. 16x to the power of 4, that is 4x squared all squared, so that is a perfect square, minus 1 is simply 1 to the power of 2, which means our A is 4x to the power of 2 and our B is 1. So now it becomes A plus B multiplied by A minus B. Now, is that the final answer? Let us check. For the first factor, again, I ask myself, any common factor? No. Is it a difference of two squares? Again, no. There is a plus in the middle, so that's the final answer for the first factor. However, it is not the case for the second factor. Why? Because first of all, it is a difference, and 4x squared is again another perfect square, that is 2x to the power of 2, and 1 is 1 squared, which means I can go further. So 4x squared plus 1 remains as is. And here we got another difference of two squares. So that is 2x minus 1 multiplied by 2x plus 1. And now it is the final answer. Let's continue. In number 3, we repeat the same process. I ask myself the first question as usual. Any common factor? The answer is yes. So we have 2 between 50 and 2. And we have y between y and y cubed. So the common factor is 2y. What is left? From the first term, we are left with 25x to the power of 2. And with the second term, it is y squared. And here a difference of two squares pops up. So this becomes 2y into 5x minus y multiplied by 5x plus y. In number 4, there is no common factor, but both terms are perfect squares. 25y to the power of 4 is simply 5y squared all to the power of 2. So I have two factors, one with a minus and another one with a plus. Our A is 2x plus 3, and our B is 5y squared, and I just repeat the same terms here. No further simplification. Let us continue with the perfect trinomials. What I mean by perfect trinomials? That simply means these two remarkable identities. So in example 1, we have x squared plus 6x plus 9. I repeat the same process. I always ask myself, any common factor? The answer is no. Is it a difference of two squares? Obviously not, because we have three terms. So let us check if it is a perfect trinomial. So it has to look like a squared plus 2ab plus b squared. And x squared is x to the power of 2. What about 9? It is 3 to the power of 2. So the first and the last terms are perfect squares. That's the first condition, which means this is supposed to be our A and that is our B. Is that all? No, because we still have to check whether 6x is 2 times A times B. And yes, it is 2 times A, which is x, times B, which is 3. So perfect. All the conditions are satisfied, and it is simply A, which is x, plus b, which is 3 all to the power of 2. Similarly, for the second question, the first term is a perfect square, as well as the last term. So our a is 3x and our b is 4y. And 24xy is 2 times a, which is 3x, times b, which is 4y. So again, it works and it becomes a, which is 3x, plus b, which is 4y squared. And again, if this were a minus, then the answer will be minus in the middle. The last case in this video will be the difference or sum of two cubes. And again, this means that I have to use these two formulas. So whenever you have sum of two cubes or difference of two cubes, we can use these formulas. In number 1, for example, x to the power of 3 is obviously a perfect cube, as well as 8, that is 2 to the power of 3, so that is a sum of two cubes. So our a here is x, and our b is 2. So the first factor will be a plus b. The second factor will be a squared, that is x squared, minus a times b, that is 2 times x, which is 2x, plus b squared, that is 2 to the power of 2, which is 4. In example number 2, we have 2y to the power of 3 minus 250. Does it seem to be a difference of two cubes? No. Well, any mistake here? Well, actually, we did not ask ourselves in the first place whether there is a common factor or not, right? And yes, there is a common factor, so we never have to forget that, which is 2. So we factor 2 first, and I'm left with y to the power of 3 minus 125. And now it is a difference of two cubes, where a is y and b is 5. So it is 2 times, we have to apply this formula, a minus b multiplied by a squared plus ab, that is 5y, plus b squared, that is a 25.